This is HEAL, Health Evaluation and Analog Logging, an integrated solution designed to bridge the gap between diagnostic screening and automated medication management. Our project requires system integration, LabVIEW architecture, analog circuitry, signal conditioning, mechanical design, actuation, data analysis, calibration, and software automation to create a system that prioritizes user safety and data-driven care. Here you can see the system in action. So we start with the joystick tests, which tests your cognitive abilities and the response time. These numbers are tracked, and then we move on to a temperature sensor, in which a IR thermopile is used to check the body temperature of the user, and this is also recorded. If the temperature is too high, a red LED will light up, indicating the temperature is high. Next, the user goes for the pill dispensing. So they put their hand under the dispenser, and a stepper motor turns gears that cause the medication to fall into the hand of the user. Afterwards, some water is dispensed in a cup for the user to drink alongside their medication. First, the system initiates a cognitive coordination assessment using an analog joystick. This is a five-step choice reaction task, requiring the user to execute a sequence of two movements in the X direction, two movements in the Y direction, and either one or two button presses. Each axis of the joystick's two potentiometers act as a voltage divider, where the mechanical position is translated into a 0 to 5 volt signal. Our software monitors these analog swings, recording a precise latency between the visual prompt and the moment the user crosses the 2.5 volt threshold. By logging this data over time, HEAL creates a map of the user's neuromotor health. This entire diagnostic gate can be bypassed for users if medication is required urgently. However, this step is highly recommended. The following step is a non-contact temperature check using an infrared thermopile. This sensor operates on the Seebeck effect, generating a microvolt level potential proportional to the infrared radiation emitted by the user's skin. Now, this is a very small level of radiation, so to translate this nearly imperceptible signal into a range compatible with our Quanser DAC, we developed a non-inverting amplifier to provide a gain of 1000. This amplification allows the LabVIEW program to detect even fractional degree shifts with high resolution. And if the system is in active screening mode, and any reading exceeding the 37.5 degree threshold triggers, an LED is lit up, alerting the user that the temperature is too high, and a prompt on the screen also urges the user to see a doctor if the temperature is in the fever range. Once the health checks are verified, the mechanical dispensing phase is initiated. The system waits for a hand to be placed under the pill dispenser, and any activity is picked up by the line tracking module, which is conveniently placed at the hand entrance of the dispenser. The line tracking module emits IR waves and has a receiver that can detect the amount of waves reflected back. When a hand is placed in the way, the line tracker detects its presence due to a change in reflected waves. The heart of the system is a stepper motor controlled by a motor driver, and unlike a standard DC motor, the stepper motor allows for discrete high-precision indexing, and we've programmed it to rotate exactly 45 degrees, aligning perfectly with our gear assembly to drop a single dose every single time. Now, when taking pills, it's important to take them with water, and the final step in our system is a hydration station, which ensures the user has enough water to take with their medication. The way it works is there's a pump sitting in a reservoir of water, and this pumps water into the cup, driven by a relay, filling up their cup. The cup is placed on top of a force sensing resistor, which acts as a weight to voltage transducer. As the water enters the cup, the decreasing level of resistance in the resistor is noted, and this is captured by the DAC and converted into real-time volume readings. The LabVIEW state machine has constantly compared these voltages against a pre-calibrated target voltage or target volume. And once the system reaches a required amount of volume or required voltage, the pump is shut off so that no more extra water is dispensed. The system also has a countdown, letting the user know when it's time to take their next medication. And at the end of the countdown, a buzzer will sound, letting them know they need to take their medication now. The system also has a countdown, letting the user know